The reason why thymic regeneration is so important is that the thymus is actually extremely sensitive to damage. And this can come in the form of everyday insults such as stress and infection. And so restoring the ability of the thymus to output and develop T cells is really important to maintain a healthy immune system. But the thymus is also sensitive to other damage, such as that comes from chemotherapy and irradiation or common cancer therapies. And so the ability to actually regenerate is really important, but it can actually take a really long time, particularly in those really severe damage settings such as chemotherapy and irradiation. So thymic regeneration is a really poorly understood process. And so what we've found now is that one particular cell type, these endothelial cells, which normally comprise the vasculature, that is to help transport blood and other nutrients around the body, these cells also have an active role in this regeneration via their production of a molecule known as BMP4. And this BMP4 targets another cell in the thymus, these thymic epithelial cells, to mediate this regeneration. And so what we have is a sort of damage sensing system where the damage comes and causes damage, and then that activates these endothelial cells to produce BMP4, and then that mediates the regeneration. So it's a bit of a loop there. So the next step for this research are, one, just to see whether we can actually take what we've found here in this endogenous setting and exploit it into a method of promoting thymic function in a clinical sense, particularly in the settings of chemotherapy and irradiation, but also in the case of age, and that is, can this be used as a kind of non-traditional way to boost immune function, to boost the effectiveness of vaccines and immunotherapy?